Hello, everyone. Welcome to my channel, Vikash Lecture on Pharmacy. In this lecture I'll discuss on unit operations. And under the unit operation I will discuss filtration. Filtration is a process of unit operation which is used to separate insoluble solid particles from a fluid, liquid or gas, by passing the mixture through a porous medium, such as filter paper. Some key terms there which you have to remember. First is filter medium. This is the porous medium from which liquids are passed and solid particles get trapped. Example: filter paper. Next, suspension. This is the initial mixture of solids and liquid which we have to separate. Next, filtrate. This is the clear liquid which is collected in the flask or beaker during the filtration. Next, filter cake or residue. This is the solid substance which is trapped and settles on the filter paper and looks like cake after the filtration. That's why it is called a filter cake. Next, filter apparatus. Those are the equipment which hold the filter medium, example funnel. Next, driving force. This is the force which is responsible for the flow of the liquid. It can be gravitational force or vacuum pressure. Now the most important part, theories of filtration. Mainly, the rate of filtration depends on two things: the driving force of the fluid and the resistance applied by the filter media. If the driving force of the fluid increases, then the rate of filtration will increase also. In the other side, if the resistance applied by the filter medium increases, then the rate of filtration will decrease. Now let's watch the picture carefully. In this picture, one person is pouring the suspension from above, and the suspension is flowing due to the gravitational force. It is the driving force of that liquid, and in the middle part of the cylinder, filter medium is placed, from which filtration is going on, as well as the filter medium applying some resistance for which the initial velocity of the liquid becomes slow. And, finally, below a chamber is present which is collecting the filtrate. If the driving force of the fluid increases, the rate of filtration will also increase. And if the resistance of the filter medium increases, the rate of filtration will decrease. So we can say that rate of filtration equals to driving force of the liquid divided by resistance of the filter medium. Now let's discuss Poiseuille's equation. Poiseuille's law says that the flow rate of the liquid depends on some factors. That is, pressure difference, radius of the cylinder, viscosity of the liquid and thickness of the filter medium. Number 1 is pressure difference. Flow rate, or the velocity of the liquid, is directly proportional to the pressure difference, so we can say that V is proportional with del P. Next one is the radius of the circular cylinder. Flow rate, or the velocity of the liquid, is directly proportional to the fourth power of the radius, or we can say V proportional with R to the power 4. Next is viscosity and the thickness of the filter medium. They both are inversely proportional with the flow rate of the liquid, so we can say V proportional 1 by eta and V proportional 1 by L. So, Poiseuille's equation is V is equals to pi del P R to the power 4 divided by 8 eta L, where del P is the pressure difference, R is the radius of the circle, eta is the viscosity of the liquid, and L is the thickness of the filter medium, and V is the flow rate of the liquid through the filter medium. Next, Darcy's equation. Darcy's law states that the rate of flow of any fluid through a porous medium is directly proportional to the filter area and pressure difference and inversely proportional to the viscosity and thickness of the filter medium. The equation is V is equals to K A del P divided by eta L, where A is the surface area of the filter medium, del P is the pressure difference, eta is the viscosity of the liquid, L is the thickness of the filter medium, and K is constant, also called as permeability coefficient. Now let's discuss about some factors which can affect the rate of filtration. First is pressure. When pressure increases, the rate of filtration will also increase. Second, viscosity. If the viscosity of the liquid increases, the rate of filtration will decrease. Next, surface area of the filter media. If the surface area of the filter media increases, then the rate of filtration will also increase. Next, particle size. If the particle size increases, then the rate of filtration will increase also. Next, thickness of the filter cake. If the thickness of the filter cake increases, then the rate of filtration will decrease. And finally, pore size of the filter medium. Larger pore size leads to fast rate of filtration. Now, let's discuss some filter media used in laboratories. First one is filter paper. Filter paper is a semi-permeable membrane which is used to separate relatively large molecules. Filtration rate is fast in this paper due to the large number of pores present on it. Next one is membrane filter. This filter medium is made up of cellulose derivatives like cellulose acetate and cellulose nitrates. The thickness of this filter ranges from 50 micron to 150 micron. The pores are uniformly sized ranging from 0.05 to 14 micron. Advantages of membrane filter. Because of its very small pore size, bacteria can be removed by this filter. Filtration is very rapid in this filter. This filter is inert in nature and does not react with the other substances. For every operation, a new disc is used so contamination will not happen. Let's discuss the disadvantages of this filter. The fine pores may be clogged easily. This filter medium becomes very brittle when dry. Next one is sintered glass filters. This filter medium is made up of glass. Glass powders are fused together and make a disc which works as a filter medium in this filter. The filter porosity is indicated by a number, for example grade 0, grade 2, grade 5, etc. Now discussing the advantages of glass filters. They can be used many times. They are easily cleanable. Like the filter paper, no particles can contaminate the filtrate. So, what are the disadvantages of this filter? They are very expensive. They cannot be used for large volume. And finally, they are fragile. Now it's time to conclude this lecture. Thank you for watching.
Please like, comment, and subscribe.